Okay, dear students, let me tell you one problem on finite group. Question is, prove that set of cubic roots of 1, cubic roots of unity is an abelian group under multiplication. What is the question? Cubic root of 1 means, what is cubic root of 1? That is nothing but 1 power 1 by 3. In intermediate we studied 3 are cubic roots. 1 omega square. How can you say 1 is cubic root? Because 1 power 3 is 1. Omega power 3 is 1. Omega square power 3 is 1. That's why these are 1 omega square are cubic roots of unity. These are called cubic roots of unity. So here what we have to prove? We have to prove it is abelian group under multiplication. Since it has 3 elements, hence we have to use group table. What is group table? First to display the elements of G as first row and first column, and then to enter this value, multiply these two, 1 into 1. Omega power 4 can be written as omega cubes. After completing these entries, come to closure law. Just examine the table. These are entries. These are all in G, is it? So write all elements of table are in G, hence G is closed. Thus, need out. That's closure. According to table, these are all in G, hence G is closed. What is associative law? Just you have to examine it. Write first associative law under multiplication. Put A1, B omega, C omega square, check, verified, satisfied. Generally, it is satisfied by every set. Okay, all of you? Any doubt? How can you write associative law? Directly write the associative law as in this way. Since all elements of G are associative, and write this one. If you got any doubt, check A1, B omega, C omega square. Check it. We got same values. Okay. Third one, identity law. Under multiplication is identity. Here operation is multiplication. Under multiplication is identity. Under multiplicative identity, 1. 1 is there. Check it. If 1 belongs to G, then G satisfies identity law. Otherwise, G doesn't satisfy identity law. Here G has identity. Write in this way. Okay, all of you? Inverse law. How can you find inverse? A into B, E. A into B, E. Coming to the question, first one is what? 1. In which element we have to multiply with 1 to get 1? 1. 1 into 1 is 1. Omega square. Multiplication is 1. Here it is in this form. AB is equal to E. In such a case, we say that both are inverses. Inverse of 1 is 1. Omega is omega square. Inverse of omega square is omega. All of you okay? Okay. How can you find inverse? We first write the product whose product is one identity, and then they are inverse to each other. Okay? So commutative law. Observing table here. First one row is this one. For one row is 1 omega square. Corresponding to one column is 1 omega square. Both are same in order. They appeared in same order. They repeated in same order. They present in same order. When omega square, 1 omega square, omega square, 1 omega. Okay? In such a case, we say that the table is symmetric. How can you say this table is symmetric? First row identical to first column. First row 1 omega square, 1 omega square. Second row identical to second column. Plus, table is symmetric, G is commutative as G is in group under multiple. Okay, all of you? Now coming to the another question. Fourth roots of unity. Listen to me. Is a abelian group under multiplication. Fourth roots of unity is 1 power 1 by 4. 1 power 1 by 4. They are 1 minus 1 I minus I. It is from intermediate. Because we know that 1 power 4 is 1, minus 1 power 4 is 1, I power 4 is 1, minus I power 4 is 1. I square is minus 1. You know that I square is minus 1, I cube is minus I. Operation is multiplication. Here G changed 1 minus 1 I minus I. Operation multiplication. So here all of you completed this table. Here you write first column as 1 minus 1 I minus I. Here you write 1 minus 1 I minus I. 1 minus 1 I minus I minus 1 minus I minus I minus 1 I into I square minus 1 minus I square plus 1 minus I minus I square minus. Table okay, all elements are in G. G is closed. Associative law okay, check. Identity okay, multiplicative identity 1, it is present in G. Just we have to write inverse law. How can you write inverse law? 1 into 1, 1. Hence 1 inverse C is 1. Minus 1 into minus 1, 1. Minus 1 inverse C is minus 1. I minus I into minus I is I into minus I 1. Here you observe that I into minus I 1. Hence inverse of I is minus I. Inverse of I is minus I. Similarly, minus I into I is 1. Inverse of minus I is I. They are mutual inverses. I and minus I. 1 minus 1 are self inverses. Table also symmetric, hence G is commutative. Okay? Can you do? Do yourself. Be fast.